The most dangerous types of snake venom are used successfully in the medical field. We have discovered natural blood thinners in the saliva of bats and anesthetic properties in that of mosquitoes. There are antibiotics in the honeycomb made by bees and cryogenic substances in the blood of amphibians, which have led us to dream of lengthening our lifespans. Water-soluble oils and bio-adhesives can be reproduced by modern engineering methods with results that are increasingly efficient and eco-friendly. While we still have much to learn, a new kind of science is coming to life, one which is adopting nature's most ingenious designs, biomimicry. And biochemistry is a source of inspiration. Life is constantly trying to spread out into new territories, looking for places where there is less competition. In other words, different species are playing a game that is ongoing and risky, on the line between what is possible and what is impossible for them. In their attempt to colonize ecosystems, certain amphibians are evolving in order to better resist low temperatures, even ones that are below freezing. Biomimicry is taking a close-up look at a battle that is overwhelmingly chemical in nature. Mammals and birds must maintain a constant body temperature. Just a few degrees above or below that number, and they'll get sick or die. The body of a frog can be at 29 degrees Celsius or at 9 degrees Celsius. It all depends on the outside temperature, whether it sits in the sun or in the shade, or whether it jumps into cold water. Some frogs can even lower their own body temperature below that of frozen water, that is, ice. This would be fatal for any other organism because cellular liquids expand when they freeze, causing the cell walls that contain them to burst. But this frog has the cryoprotective substances glucose and glycerol, which when combined, slow down the freezing process of the animal's cytoplasm. In addition, this makes it necessary for temperatures to drop even further before freezing can occur. Because of this ability, each year, this species is able to live at higher and higher altitudes in the mountains. Holding out 1 or 2 days more than other frogs in these brutal conditions could mean the difference. Surviving when others cannot. Biomimicry is still far from fulfilling the dreams of Walt Disney, but we have already begun to freeze organs and cells, which have been used to save many lives. Every species of bacteria, fungus, plant, and tree develops its own venom to keep other species from growing alongside it. They release toxins or scatter tannins on the ground or make their leaves bitter so they won't be eaten. We have learned many chemistry lessons from the substances we extract from the plant kingdom, leading to pharmacological development. The most ancient branch of science is green biomimicry. Thanks to the analysis of a variety of plant formulas, we can either heal or kill. We are masters in both cases. But in the world of plants, a far more valuable secret remains undiscovered: photosynthesis. The control of sunlight in order to convert carbon into living matter. The power of the sun, the cleanest and most abundant energy provided by the universe, is utilized by every single leaf on a tree. No other living being is able to directly capture the atmosphere's carbon dioxide. And what's more, plants convert carbon into something living by including it in their very cells. We have learned to capture the rays of the sun to heat up panels and use that heat to our benefit. But the latest in biomimicry involves a plan to build photosynthetic vehicles. Without a doubt, this would be a safe and clean revolution for all those living on the planet. Biomimicry looks in all directions, because even the most dangerous aspects of nature can be home to marvelous and useful biomolecules. Of the 2,000 snake species that exist, only 15% are venomous. Only a few are poisonous because, speaking in an evolutionary sense, harnessing chemistry is no easy feat. Snake venom is made up of about 20 polypeptides, combinations of 200 amino acids, designed to contaminate the blood or cells and alter the operation of an organism's neurons. If this process could be controlled, it would be extremely valuable in the medical field. We could kill select cells or regulate neurotransmission processes in our nervous systems. The keys to that control would have to do with dosage, becoming familiar with the effects of each toxin, and, of course, knowing how they are used. Different kinds of snake venom feature varying effects, but none of them are effective when ingested through the intestinal tract. That's to say, a hunter doesn't die when he eats an animal that has been poisoned. But if one snake were to bite another, even if it were the same species, the venom would enter it through its muscles or veins, and it would suffer the same effects as any other animal. This is an African viper. The Bitis arietans is one of the most efficient venomous snakes on Earth. Its poison has cytotoxic effects. And although mamba venom is even more destructive chemically speaking, this viper's bite is much more effective. Its fangs are long and sink deep into the body of its prey, where it releases great quantities of venom. To keep from being wounded during an attack, venomous snakes devised a strategy of bite, poison, release. They allow their poisoned victims to escape temporarily, follow their trail, and then eat them once they are too incapacitated to defend themselves. A mouse might be small, but it's agile and fast, and its rodent teeth could perforate an eye. The chemical effects of the venom in a mammal's body are rapidly apparent. The prey is dead. Its spasms are an effect of the poison, but it's no longer suffering and poses no danger to the snake. By observing different types of snake venom and their effects, biomimicry scientists have begun to successfully apply them to medical treatments for illnesses ranging from serious heart disease to cancer. The most potent vertebrate venom known to man happens to be a defensive system, an element of protection, and not a weapon used to attack. Batrachian toxin is an alkaloid that turns these colorful minuscule frogs into untouchable animals. At least for those who know enough about what such bright colors mean. Unlike snake venom, which is made by each reptile, the poison of the dying dart frog is synthesized from toxins that are ingested when eating certain ants and some unknown insects. The frogs do not sting, or bite, or spit, or project their venom over long distances. They only exude the poison if they feel threatened. In some cases, merely touching them can result in death. The Phyllobates terribilis is the most lethal of the entire family. The skin of a full-grown golden poison frog has 1 milligram of batrachotoxin, which can be enough to kill more than 10 people. Natives living in the Amazon rainforest have used them to hunt for thousands of years. But now scientists have discovered their powerful anesthetic properties, which are up to 200 times more effective than morphine. The most significant source of inspiration for biomimicry is most probably found in the tiny world of insects. There are millions of known species, and millions that have yet to be discovered. Theirs is a universe that is subject in large part to the laws of chemistry. Fireflies produce a chemical light by mixing luciferin with luciferase, generating energy which is heatless and non-polluting. The insect's pheromones travel through the air from one body to another, communicating their availability to potential mates. It has been proven that some butterflies can locate each other chemically at distances of up to 25 kilometers. As much as or more than the plant kingdom, insects are masters of chemistry. Wasps have developed substances that help them defend themselves by inflicting pain. This is their only objective, to drive enemies away from their nests. But wasps are quite dangerous, and their stings can prove fatal to humans. Bees can also kill if they attack in large numbers, but their sting is entirely non-toxic. When they sink their stinger into the victim, part of their intestines is also injected, which can cause pain and even infection. For the bee, activating the stinger means certain death, although none of them hesitates to sacrifice itself for the colony, its larvae, or its honey. The chemical mastery of these social insects is much more sophisticated than venom. Honey is a marvelous liquid created by bees when they mix flower nectar and plant substances together with their own saliva. Its composition makes it the most complex substance in existence. It has a variety of extremely sweet sugars, including fructose, glucose, and sucrose. Acids include acetic, citric, lactic, oxalic, and formic, among others. There are amino acids and enzymes and proteins and minerals like potassium, sodium, magnesium, and calcium. Finally, there are different alcohols, aldehydes, esters, ketones, and another 100 substances that are extracted from the plants of every region in every season for the sole purpose of adding aroma. Honey is a super brew. It has so many uses that we still haven't discovered them all. It's so valuable that bees have invented another substance just to keep it clean and healthy while being stored. Honey is almost alive. It even ages and matures like a fine wine. That's why beeswax has 7 different kinds of antibiotics. There is no other place in the world as clean and disinfected as a honeycomb. These are baby squid. Some are still inside the egg. Others have just hatched. And they already know how to use the chemistry of color. The process they use to change their appearance is similar to the one used by chameleons, but even faster and more effective. Their intention is to threaten possible predators by appearing to be dangerous and toxic. Experts in biomimicry are designing materials that can change color by absorbing or reflecting light. The visual information codes we use in marketing and traffic signs, for example, are based on these same principles. Colors in nature are generally determined by the chemical substances that make up each material. Our eyes perceive color depending on how the pigment molecules found on each surface absorb or reflect light. We don't see things at night the same way we do in the daytime. There are thousands of colors of organic pigment, But the most important of these are the ones we've labeled basic or primary. The blue sky in summer, the yellow of this lemon snake, the red of a poppy. The pigments responsible for these tones, combined in different proportions, give each thing its chemical color. As we all know, in order to make purple, we just need a bit of red and a bit of blue. And to make orange, just mix yellow with red. Colors have many uses. They favor thermoregulation in animals whose body temperature varies greatly, such as reptiles. Depending on whether they need to warm up or cool down, they get lighter or darker. Different coloring also allows animals to defend themselves by hiding. But more than anything else, it helps them to identify themselves and communicate with one another. Chameleons can even change their color. They speak with their skin. The different pigments in their epidermis are stored in tiny compartments that can vary in size, allowing them to change the mixture of primary colors and change, for example, from green to yellow, or from brown to red. Chameleons are quite territorial, and they communicate with each other by changing their skin color. Their moods can be determined by looking at how bright their spots are. This can often help them prevent fatal encounters. Females also consider color when selecting a mate. Although, today, that decision is easy. Biomimicry will be able to extract good ideas from the chameleon's chemical makeup. But it would be even more useful to analyze the adhesive substance on its tongue. Which is unbelievably quick. What's more, the adhesive is edible, which would also make it biodegradable. A spider's silk is not just a thread for webs. They are sticky strands with a very sophisticated chemical makeup. But they weren't always sticky. And they weren't always used as traps. In the beginning, they were simple threads that made up part of their houses, protecting the animals from the cold terrain. The components of this material are admired by modern human engineers. It is resistant, but also biodegradable and exceptionally light. The secret to this revolutionary material are several supermolecules that the spiders spin by controlling the pH level in order to keep it from coagulating. They can spin silk in various thicknesses depending on what is needed. from 10 microns down to just 1. It's stronger than steel, with even greater elasticity. Spider silk is composed of chains of amino acids, especially glycine and alanine, which are made up of proteins. We humans are learning to fabricate this material, whose most amazing use is as an element in sutures for microsurgery. Most spider webs also have an adhesive component which is sticky, but also soluble in water, making them incredibly ecological. This is a necessary advantage, making them digestible. Although when it rains, they're no longer sticky enough to capture their prey, their only defect. It's no easy feat to design an adhesive that works even when wet. Only very recently have we humans invented substances that are capable of gluing things together underwater. But these female newts have been doing just that for millions of years. Now they are in the thick of mating season. When a pregnant female lays her eggs, she doesn't do so in a cluster or a long chain like frogs do. Instead, she lays them one by one in hidden spots. What she does is to look for a leaf that is clean and in perfect condition. When she finds one that looks good, she lays her egg on the inside of the leaf and then uses her hind legs to carefully wrap up the treasure. As she lays the egg, she also secretes an adhesive that takes effect after about 15 seconds, during which time she lies still on the leaf, ensuring that the chemical will work correctly. There. Now hidden from predators, her baby will have a better chance. Of course, the formula for this adhesive must also be odorless so it doesn't draw attention. That's certainly something biomimicry could look into. An odorless glue. Architects, engineers, and designers of all types are seeing nature through new eyes, seeking inspiration from living beings in order to create new inventions in a way that is both revolutionary and responsible. From coral reef structures, we are learning self-assembly techniques that can be employed to join other materials that do not contain pollutants. These biological creations have been tested for millions of years and have proven not only their effectiveness, but the fact that they are environmentally sound. Often, the best ideas come from the simplest places. Some animals have an appearance that is so distant from our own that they seem to be aliens. Snails are a culinary delicacy in certain parts of the world, although for many people they are less than appetizing, partly because of their texture and the sticky slime that covers them. But it is in this very slime that the cosmetics industry has discovered important qualities for healing and regenerating the skin. When a mucopolysaccharide comes into contact with water, it swells up and forms a sort of gel that is both moisturizing and protective. In addition to reducing friction and informing other snails of their sexual availability, it also filters the sun's ultraviolet rays. Snails have skin that is delicate and thin, which explains the many qualities of this secretion. The polymers in the mucus secreted by this giant slug species are among the most resistant in this family of mollusks. Its density is such that the animal moves about atop a moving fluid without its skin touching the ground, whether it be rough or smooth. The movements of its foot happen within the layer of mucus, which is dense and shiny. The lubricant developed by the slug not only helps to lower friction, but it is so strong and sticky that it has also become a powerful defense. We never see a bird, reptile, or mammal, like a fox, for example, devour one of these slow creatures, even though they are so juicy, so succulent. It must not be worth it to get a mouthful of gluey adhesive so strong and awful tasting. Maybe the ants, who make use of everything, would face danger to get a taste. But they can't grasp the meat of the colossal animal with their pinchers. And those who try end up drowning in the sticky mucus. This one got stuck to the monster, like Captain Ahab and Moby Dick. Scientists have tried to imitate many of the substances like adhesives that animals and even plants have designed. Some of them have still not been matched. But the biggest open question for science is how to produce something as well as nature herself does, whether adhesives, lubricants, or oils. The body temperature of an animal in contact with water falls 4 times more quickly than one in contact only with air. Many animals on dry land can resist temperatures close to 0 degrees Celsius. But submerge them in water at the same temperature, and they will die in just a minute or two. Perhaps this idea explains why we often see aquatic birds running their beaks through their feathers. They are spreading around a water-resistant oil that is produced by specific glands to keep the water from touching their skin. The layer of air created by their feathers completes the isolating effect. This is how the white-throated dipper has managed to adapt to spending so much of its life underwater without worrying at all about freezing water temperatures. Even so, sometimes you have to get wet. We all have to bathe. Although some of us do it more often than others. A dirty animal would smell so foul that predators would be able to find him. Or he might be rejected by his mates. A dirty body could result in a strong odor or even parasites. The body must be washed and the skin cleaned, and water is best for this job. For birds, who are often oiled, brusque movements are the only way to open up gaps in the feathers where the water can enter and clean the skin. But water isn't always enough. Sometimes chemical agents must be used. In rare instances, some birds bathe in another way, one that uses no water at all. It's a curious chemical bath, performed by a special kind of ant. These are members of the European Formica rufa species. Their behavior is difficult to spot and isn't visible in all parts of the world. This kind of ant is rare and doesn't live in many ecosystems. It's normally found deep within the forest. Only woodpeckers and certain kinds of crow, like this jackdaw, have discovered the secret benefits of formic acid. The bird's behavior is innate. When the ants feel threatened, they know they must defend their colony by spewing acid on the attacking enemy. The acid shower produced by the insects acts as a sort of anti-parasite treatment for the bird. But the ants also bite the bird, causing it great pain, especially in the feet, and often causing it to flee. But the jackdaw returns, refusing to give up. It appears that the chemical benefits of the ant's defense is worth it. It could be considered a healing medicinal bath, which is why the bird is willing to undergo a certain level of pain as long as he can withstand the furious ants. Formic acid is used biomimetically to increase anti-corrosive and lubricating capacity in certain industrial fluids. It can also be used as a sustainable treatment for skins and leathers. Biomimicry sometimes finds very different uses for the same substance. In addition to being polluted, the sea is filled with plastic. It may not be visible from the shore. It may only exist in isolated spots, but there are entire islands in the ocean made of plastic bags and trash, brought together by the currents. Our landfills are also full of plastic. It may have been a revolutionary material in the 20th century, but we're going to have to find a way to dispose of it and handle its contaminating effects. Perhaps a clean, abundant, cheap, biodegradable replacement can be found in the skin of insects and crustaceans. Chitosan, a material that could substitute for plastic completely. A Spanish scientist at Harvard has closely analyzed the chemical structure of the exoskeleton of these animals. The proteins found in these structures can be as rigid as they are elastic, depending on whether they're part of the main armor or a wing. In addition, they have an external layer which is similar to water-resistant wax. The researcher observed the ability certain sucking insects have to control their rigidity when they puff up to absorb the blood of other species or the sap of plants. This new material inspired by nature could have the same uses as plastic. But chitosan is twice as resistant and has significant medical uses. Perhaps now we can begin to appreciate the shrimp heads or crab shells we casually throw away after eating the tasty part of those shellfish. Next to plant-based cellulose, the exoskeletons of arthropods are the most abundant organic product in nature. So maybe someday not too far in the future, we will see the true value of this immense biomass. But not everything in these zoological classes is beneficial. The mosquito may be the most dangerous parasite in the world. Although the damage it causes is not due to its own chemistry, but rather to the transmission of pathogenic microorganisms associated with its tiny bite. They suck only a small drop of blood with each microtransfusion. But at the same time, they can cause the contagion of terrible illnesses, like malaria. It may not be intentional, but no other animal is indirectly responsible for so many human deaths. On the other hand, they can be considered one of the most successful animals produced by evolution. Proof can be found in the vast quantity of mosquitoes in all of the Earth's ecosystems. And they have existed for millions of years. They have sucked the blood of dinosaurs, And today, they drink the blood of humans or whoever else, regardless of the thickness of their skin. They always find their victims' weak points. They use the same technique and tools they always have. Their mouth parts consist of a very thin and hollow elastic needle and can be used to suck or expel. Its chemical mastery is found in the substance it injects, an extremely powerful anesthetic which takes effect immediately. In just a few seconds, the mosquito's belly swells with blood. As we've seen, its body is flexible, although everything has its limits. Mosquitoes may kill us by the millions, but molds and mushrooms have been used for healing and as antibacterial agents for more than 3,000 years in China, Egypt, and Central America. The penicillin fungus has saved millions of lives. This great source of antibiotics was discovered by Fleming, who saw it could be used to keep bacterial infections from developing in our bodies. Today, we are still researching natural antibiotics to improve their clinical applications. In the wild, there are problems and solutions. Nature inspires the science of biomimicry. It's a nearly unlimited field of practice. But we must be respectful, even as we study it and take advantage of its wisdom. From the beginning of time, the different kingdoms have led us to countless chemical products. Their discovery has allowed us to evolve like no other living being before us. Many of these substances haven't even needed to be processed. They are all extremely useful formulas with endless applications, but they were not made for our purposes. We must use them with care. They represent millions of strategies, as many as all the existing species engaged in a huge war that is eminently chemical, but which somehow maintains its equilibrium. Nature offers its solutions up free of charge. In using them, we can live lives that are better and more balanced. It's only logical that we must respect the source of our knowledge.